Hello, 8th graders, and welcome to lesson 6.7, which is about geometric sequences. So far what we've been doing in this unit is we've been talking about exponent rules, and then I had mentioned we were going to start talking about scientific notation. For some reason, I don't know why this got mixed in with this unit, but we are going to start with these geometric sequences, and then from there we're going to start talking about scientific notation. So before we get too far into this, we also talked about arithmetic sequences early on this year. Arithmetic sequences were where it was a pattern going on and we were talking about addition. Okay, so I'm adding 5 to each numbered position number in my sequence. Okay. Geometric, as you're going to see here, is a little bit different, and we're going to do a few activities that I should be sending in your packets or here online to help you practice the difference between the two. So your objectives for this lesson are I can extend and graph geometric sequences, as well as I can write equations for geometric sequences, and I can solve real-life problems. All right, skip and warm up. So like I said, how are geometric sequences used to describe patterns? So the biggest thing is understanding, okay, what makes it a geometric sequence versus making it an arithmetic sequence? What is happening between those numbers every time you jump positions? All right, so it says a geometric sequence. In a geometric sequence, the ratio between consecutive terms is the same. This ratio is called the common ratio. So this is something we also saw in our arithmetic sequences where we had a common ratio. Something was always going to be added by 5 or added by 10. Okay, that's still the same. You're still going to have your common ratio. It says each term is found by multiplying the previous term by the common ratio. So this time we're seeing that everything is going to be multiplied. Okay, so we see that it jumps from 1 to 5, we're multiplying by 5, and that pattern should continue on. Okay, 5 to 25, yes, that's a multiple of 5. Okay, 25 times 5, yes, that gives me 125. So here is my common ratio is multiplying by 5, or 5. Okay. The other part then we're going to get into is being able to write your geometric sequences as an equation. So here is your equation. Please circle that on your notes. Okay, it's going to be important that you understand how to set these up. So again, a to the n, it says let a to the n be the nth term of a geometric sequence. So maybe you're looking for the 25th term, okay? With term a1, so that's going to be that first term that you see. So the first term in that sequence. So in this case, if I was going to write an equation for this one, I would put in 1. And your common ratio is 5. And then the nth term is given by this equation. Okay, so if I'm going to write an equation for this geometric sequence, maybe I want to find a to the 10th, and I don't want to sit here and continue to write out numbers. So I have a to the 10th as my a to the n. My a1 then is my first term, which is 1. And I'm going to multiply it by r. So my r is 5. And then I'm going to put it to the power of n minus 1. So I'm using that same n that we put over here, n minus 1, so 10 minus 1, and we're going to simplify that as 9. Okay, so then I can figure out what is 5 to the 9th, multiply it by 1, which is going to keep it as 5 to the 9th, and that's going to be my term for the 10th term in this sequence. All right, so let's go ahead and take a look at some official examples. All right, so here is example 1. It says write the next 3 terms of your geometric sequence. So what we need to do is we need to find what is that common ratio. So what is happening between these numbers. So if I'm jumping from 3 to 6, it jumps 3. If you're thinking addition. 6 to 12 goes to 6. So think about your multiplication. 3 times what would give you 6? Okay. That was thinking arithmetic sequence, so thinking geometric, I had to think multiplication. 3 times what gives me 6, so that's 2. Does that work when I go from 6 to 12? Yes, that does work, and I want to make sure that it still works when I go from 12 to 24, and it does. So what I need to do is find the next 3 numbers. So I'm always going to take that previous number and then just multiply it by 2 in this case, because that's my common ratio. So 24 times 2 would be 48. That would be my next one. Take my 48 times 2, that's going to give me 96. And then from there, taking my 96 times 2, which would give me, 180, 192. I'm going to double check that one with the calculator here, just in case. Six times 2. Yep, 192. Okay. So there are my next three numbers within my geometric sequence. Remember, if you want to use a calculator, feel free to use the one you have at home. You can use one online here because I'm going to also be using that online graphing calculator in a little bit, just because it's easier for me to graph that way on the computer here. Or feel free to use your phone when graphing as well, or using a calculator. All right. So the next one, example 2, like I just said, is we are going to actually graph this geometric sequence. And they want to ask, what do you notice? So we just want to be able to evaluate that graph and explain what's happening in that graph. Okay, is it linear? Is it nonlinear? Is it a function? Is it not a function? What do you notice about this graph? Is it positive? Is it a negative slope? Okay. So remember, when we do this, we set these up with what position number they are. So your x value is going to be what position number it is, and then your y value is going to be this number in the sequence. So in this case, for this one, I'd have a point at 132. This one would be 216. This one would be 3, 8, 4, 4, and then 5, 2. Okay. I'm going to pause the video here for just a sec. I am going to upload that graphing website, and I'm going to plug these data points in, and then I'll show you what my graph looks like. Okay. To you, it won't really look like I paused it, but it'll just jump right to the next slide. Okay. All right, here's the graph that I created given that set of data. So all I did was use the online Desmos and plugged in my points here, and they graphed them for me. And so the biggest thing that we wanted to do was, when taking a look at this, is just to be able to describe the graph really. So from this graph, what I can notice is that my first point was here, then I went down here, 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 here. So this is a graph that is decreasing, as I can tell, because my y values are getting smaller as my x is getting larger. So I would say that this has a negative slope. But if you can notice very closely, if I was to draw a line through these are not straight, because if I was to draw it straight, it would just kind of go like about that. So it starts to kind of curve. So I would say this is non-linear, or if you wanted to say something like exponential, because we talked about exponential growth as well when we were watching those brain pop videos. That would be another good way to describe this situation. So I'm not necessarily going to write it here in the notes, but again, what I would do to describe this is I would say it has a negative slope. It's non-linear, and maybe even describe something about it being an exponential. And I wouldn't say exponential growth, I'd almost say an exponential decay, meaning because it's getting smaller, it's not growing, it's getting smaller as we go down. So we're decaying it or making it smaller. Okay, so I'm going to go back to the slides here. Give me a minute. So again, I was just kind of making observations on what did you notice about the graph. Let's go ahead. Okay. All right, so for the next part on your own, write the next 3 terms of the geometric sequence. I'm going to say don't worry about graphing this, okay? Because for the most part, our graphs are going to kind of happen to be very similar to the ones that I just created. Whether it's going in the positive direction or if it's going in the negative direction, it's going to still be nonlinear as we kind of described here. So go ahead, pause the video. I want you to come up with the next 3 sequences of the geometric sequence. So figure out what is either being multiplied or what is either being divided by. Because in this case, as we know, it was decreasing. So in this case, I could use multiplication still, but I would say it's being multiplied by 1/2, which is then the same thing as dividing by 2. So if it's easier for your brain to think about the division part, You can do that as well in geometric sequences, or you can think about it as being multiplied by a smaller number, so something like a fraction. Okay. Let's pause the video. When you get back, I will have the answers for each one. Alrighty, welcome back. So again, I was just looking for your next 3 terms in your geometric sequence. So figuring out what is that common ratio. So for number 1, the common ratio is multiplying it by 3. So I'm just taking the previous number, multiplying by 3, so 27 times 3 is 81, so on, so on, okay? Number 2 and 3, I both said you can change these to division if it's a little easier for you, but so I used a division of 4, but it would mean the same thing as multiplying by 1/4, okay? So what happens here is I take this 1, I divide by 4, I end up getting 1/4. I take 1/4, divide by 4, I get 1/16. And 1/16 divided by 4, I get 1/64. So basically, it's kind of going back in the other direction that it was going here. It's just now these numbers are at the denominator part of my fraction. And then number 3, like I said, division. So you could use this division. And what happens is I'm dividing by a -2 as I go through. So that's why we were seeing some of it positive, some of it negative. If I wanted this to stay in multiplication form, it would be like saying multiplying it by -1/2. Okay. So if I take -10 divided by -2, remember when we are using those integer rules, they cancel out, make it positive. So again, that pattern is going to continue on of being a 1 positive, 1 negative, 1 positive. So here are my solutions for this problem. Okay. Again, at any point, if you need to go back and rewatch any of this, you can go back, or you can go a little bit ahead if you need to. Feel free to reach out to me either on Remind, on text messages, or even on email. Make sure that you are watching out for the code word for this video as well. Don't feel like I forgot about it. Remember that code word is going to be important because if you come to me with any questions or any concerns, I'm going to ask for your code word. Or at any point, I could just be like, hey, what's the code word for this lesson? Okay. All right. We're going to move on to example 3, but I think this is actually a perfect time to pause the video because, again, I can only record up to about 15 minutes, and I don't feel like I'm going to get through explaining example 3 here in the 2.5 minutes that we have left, or 1.5 minutes we have left. So please make sure that you go and find part 2 of this lesson. I will see you back then. Let me know if you have any questions.